Alright, calculus, we're taking a look at these sample tests. Numbers 1 through 9 is what we're going to start with. We have the multiple choice and then the free response questions, and we're going to split this up into multiple sections. We're going to be doing these in groups of 9 for the multiple choice. So that's 1, 2, 3, 4, 5 videos. These first 3 are non-calculator. The next 3 are calculator, and then for free response it's going to be 3 questions and 3 questions calculator, and then non-calculator. So that's going to be how we split this up. So here's the first video. If you look at this, oh my goodness, that is a lot of videos. This is really one video, and this is one video. So that's 1, 2, 3, 4, 5, 6, 7. All for one test. Let's get going. Okay, so first question here, number 1. If f is continuous. Okay, that sounds interesting. Continuous sounds like a keyword. And we have a piecewise. Okay, so I got piecewise and I got continuous. That tells me that the left piece has to equal the right piece. And of course the middle has to be in there too. The middle's wrapped up in this top one. So let's get more specific here. That means that x squared plus bx has to equal 5 sine times pi over 2 times x. Okay, so what's b? Wait a second. It's a piecewise. The split is at 5. So I know that x equals 5. Alright, so that's where the left has to equal right, at x equals 5. So this is going to be 5 squared plus 5b equals 5 times sine of 5 pi over 2. Okay, now 5 pi over 2, that's a little confusing there. So let's think about that. 5 pi over 2, that's really 2 pi, because it's like 4 pi over 2 plus pi over 2. So it's 2 pi plus pi over 2. And when we're talking radians or trig measures, 2 pi is one full circle, and then pi over 2 is one more quarter circle. So we're right here, up and down. Okay, so what's sine of pi over 2? That would be sine of pi over 2. That's going to be 1. Yeah, 1. Okay, so that's 1. All right. So let's simplify this just a little bit further. We're going to have 25 plus 5b equals 5 times 1. Alright, now it's algebra. So I'm going to subtract 25 from both sides. That gives me 5b equals negative 20. So divide by 5, b equals negative 4. Alright, so b equals negative 4. C, that's the answer. Check. Move on. But the big idea is continuous. Piecewise, left equals right. Next one, number 2 here. Let's make this bigger so we can all see. The graph has a relative maximum. Ooh, that's interesting. Relative maximum. I know that relative maximum happens when y double prime changes from positive before, negative after, and 0 in the middle. This is a max. So I got to figure out, when does this happen? So x equals what? When does that happen? Notice I don't really care what y equals, because as long as I can determine it based on the x values, I can at least look at these. Now, chances are, let's talk about some test-taking strategies. I can almost guarantee that b and d are not going to be options. Why? Because I got this combination of 0 and 2, 4. Then I got 2, 4, and 0, 0. So chances are those two are not going to be options. Chances. Not guaranteed, but there's a big chance. Well, let's start from the top. We have y, but we need y prime, because that's really what we're looking for to make this analysis. When do we change from increasing to decreasing? Well, y prime, pretty simple derivative here, 6x minus 3x squared. All right, so at this point, I would probably try to find my critical points. To find my critical points, I would say 0 equals 6x minus 3. Well, let's factor that too. I could factor out a 3 and an x. That would give me 2 minus x. Okay, so that tells me that x equals 0 and x equals 2. So that's kind of interesting because that would be both of these, 0, 0, and 2, 4. But I'm looking for relative maximum. And because I'm looking for relative maximum, I got to make some comparisons in my y prime. So let's do that. So if I do a little sign chart here, x and y prime, and then let's see what that's going to tell me about y. So if I'm looking at 0 and 2, I got to check in between those. So in between those, I would have like 1 and -1 and 3. So at 0, I'm 0. At 2, I'm 0. That means I'm flat here and I'm flat here. But at -1, if I were to plug that in here, y prime when x equals -1, well, that would be -3 times 2 minus -1 is 3. 3. 3, like that. So that's negative. That's less than 0. So this is negative here. If I were to plug in 1, that's a little bit easier, dealing with negatives and positives. That's a positive times a positive. That's a positive. If I were to plug in 3, that'd be 9 times -1. That's a negative. So what does that mean is happening? Well, at first here we are decreasing when this y prime is negative. Then we are increasing when y prime is positive. And then we are decreasing again. One of these 2 points, well, both of them are relative extrema, but only this one is a max. The other one is a min. So 0, 0, that's a min. So that's out. A is out. The answer is C. Easy peasy. Lemon squeezy. Number 3. Okay, this one, I was working on this one with a student, and I was like, oh, that's rough. That's a little tough there. So let's look for some clues. Let's do some problem solving here. It says a line through the origin. Whoa, that's got information packed in it. Through the origin. That means that we have a line. Here's my x and y axis, and then I have a line that's going through the origin like this. It's passing right through the middle. That's not the best looking graph, but close enough. Let's make that eraser a little bit smaller. Clean this up. There we go. Alright, through the origin. Rotates. Ooh, rotates around the origin in such a way that the angle theta between the line and the positive x-axis. So we're talking this angle right here, theta. So this theta, it changes. So d theta dt is something right here. And we know that t is greater than or equal to 0. So we're rotating this way. Or this way, actually. We could be going either way. It doesn't say we're increasing or decreasing. So which expression gives the rate at which the slope, slope of the line is changing? All right, let's talk slope. We know slope equals rise over run. And in this case, the rise would be the vertical. So that's our vertical side. This is going to be our rise. And horizontal, this would be our run. So slope would be this one over this one. But we look at all of our answers here. These are all in terms of theta. We have d theta dt, 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 all over the place. So I got to make a function using rise and run with this slope thing. So slope isn't really rise and run. Slope would be this ratio of rise over run. But is there a function with theta, something of theta that equals rise over run? There is, actually, because this is theta right here. And rise over run would be the opposite side over the adjacent side. So thinking SOHCAHTOA, that would be TOA or tangent. So tangent theta equals the rise over run, which equals the slope. So slope equals tangent theta. It's asking what's the rate, or what's the ddt of slope. So I got to take the derivative ddt of both of those. So I take the derivative of tangent. Well, that's not too hard. That's secant squared. So that's going to become secant squared theta. Then we have this d theta dt, chain rule, implicit differentiation. That's why we have the d theta dt. So the original function was tangent, but the derivative was secant squared, so that one's out. And it's squared, and the only one that I see it's squared is this one, and that should be pretty obvious because it's also secant, because secant is 1 over cosine. So that, for sure, tells me it's this one. d theta dt, this would be like 1 d theta dt. And that might be true if it's changed at like a constant rate, but that's really not what it was asking. This is not an easy problem, guys. I realize that. But the big idea here was to realize that you have all these thetas, so slope had to be written in terms of theta. That was the big idea. And then derivative from there was not too bad at all. All right, let's look at number 4. Remember, all of these are non-calculator, these first set here, the first 3 sets actually, numbers 1 through 27, or 28 or so, something like that. Non-calculator for all those. All right, we have if f of x equals e to the sine x, how many zeros does f prime have on the closed interval? Okay, so here's f of x. F prime of x would be the derivative. Well, the derivative of e to the u is really e to the u times du dx. And in this case, u is sine x, so du dx is cosine x. Easy enough. So f prime of x then is e to the sine x times cosine of x. Now here's where it gets a little challenging. We're trying to figure out when does that equal 0. That's what it's saying. How many zeros? Well, okay, let's do some fancy algebra here. We know that this first term times the second term would multiply and we have to get 0. E to the sine x, well really e to the anything does not equal 0 because it's an exponential function and there's no constant to kind of balance, or there's no like plus c out here that would help balance this out to a 0. It's always going to be either a negative or a positive number. In fact, this is actually always going to be greater than or equal to 0. So there's no way that equals 0. So there's no way that e to the sine x, that cannot equal 0. Does not happen. So if this term cannot equal 0, then I'm going to look at the second term, cosine of x. And when does cosine of x equal 0? On the interval 0 to 2 pi. Well, it actually does it a couple times. So there's 2 ways we can think about this. Here's a graph with x, and here's like f, or not x, let's say this is y, and we would go from 1 to -1. Cosine does this, boom, boom, from 0 to 2 pi. That's just some background knowledge of cosine. Let's say I want to use unit circle. Cosine generally represents the horizontal or the x value. And as we're rotating around in a polar direction, we see, we hit 0 here and here. Twice. So how many times does it happen? 2 times. Excellent. Number 5. Ooh, this one's easy. This is a gimme problem. This is like super fast. So, buzzwords, keywords, things that happen. X approaches infinity. So when x approaches infinity, key thing would be divide by the greatest power in the denominator. So let's rewrite all this junk, but we're going to multiply by 1 over x to the 6. Why x to the 6? Because that's the greatest power in the denominator. 1 over x to the 6. We're going to multiply this to everything. So we're going to have the limit as x approaches infinity of 10 to the 8th times x to the 5th over x to the 6th, which is really 1 over x. And then we have 10 to the plus 10 to the 6th times 1 over x squared. When we simplify x to the 4th and x to the 6th, that's what happens. Plus 10 to the 4th times x squared over x to the 6th, which is really 1 over x to the 4th. All over 10 to the 9th times x to the 6th over x to the 6th, that's just 1. There it is. That's the key term. Plus 10 to the 7th times x to the 5th over x to the 6th is going to be 1 over x. And the last one, plus 10 to the 5th times x to the 3rd over x to the 6th is 1 over x cubed. So, the limit as x approaches infinity of 1 over x to the n, where n, is greater than or equal to 1, equals 0. Maybe it's n is, yeah, where n is greater than or equal to 0. Goes to 0. This equals 0. So that means this piece here, that goes to 0. This piece here, that goes to 0. Why? Because they have an x in the denominator. Because 1 over infinity equals 0. When you plug in infinity into a denominator, those pieces go to 0. So does this, so does this, so does this. So that gives me 0 plus 0 plus 0 over 1 plus 0 plus 0. No, wait, not 1. 10 to the 9th, which just equals 0. Booyah! Number 6. Alright, so this one has a couple of parts to it. Let's look at the problem first, and then we'll take a peek at these answers down here. It says the graph is shown above, but it's a graph of h of x. Which of the following could be a graph of h prime? So here's the original graph. It's asking, what about h prime? Alright, so if I see this here, at this point right here, h prime of x should equal 0. Similarly, here, h prime of x should equal 0. Now look at these other points. What's happening going down this way? This should be h prime of x is negative. And then here it's positive. And then here it's negative because then it goes up, then it goes down. So I should have 0, positive, 0, and negative on each side. We're negative, then we're positive, then we're negative. And we got zeros in the middle. 0, 0. What does that look like? Hey, that looks like B. How do I know it's B and not E? Well, here's why. Because look at B. It's got negative values down here, but then it's got positive above the axis there and then negative. It's not E because even though it has that similar shape, it's negative, but then it stays negative. There's no positive. And D, it has positive, but it needs negative. There's no negative. For A, it's backwards. It goes positive, then negative, then positive. So that one's out. For C, it's totally confused. Alright, let's look at the next one here. Number 7. Dun, dun, dun. F prime of 0. What's F prime of 0? Well, to find F prime of 0, first we need to figure out what F prime of x is. Well, before we even figure out what F prime of x is, let's go even simpler and look at just f of x. Can I rewrite f of x in a way that makes it easier to take the derivative? You betcha. I see f of x equals this, but that's really that inside piece to the 1/2 power. So we're going to have 4 sine of x plus 2 to the 1/2 power. So here's f of x. F prime then, in this case, is going to be a chain rule. Well, let's start with the outside, then get to the inside. So first the outside, that's going to be a 1/2 out front, drops, and then subtract 1 from the power, we got negative 1/2. Now for the other two parts, we'll have 4 sine of x plus 2. Then we got to take the derivative of that inside piece. Well, the derivative of the plus 2 part, that goes to 0. This 4 is a constant, so that's going to tag along. The derivative of sine of x is cosine of x. There we go. So that's our business. Let's see if we can maybe simplify some things here. I know that I have 1/2 here out front. We are going to have this 4 sine of x plus 2 to the negative 1/2. Negative means it's down in the denominator. So that piece is going down here. And it's square rooted. 4 sine of x plus 2. Then the 4 cosine of x, that goes up top. 4 cosine of x. So let's see what we can get if we plug in 0. F prime of 0 equals 4 times cosine of 0. Then we'll have 2 times the square root of 4 times the sine of 0 plus 2. Well, cosine of 0 equals 1. Sine of 0 equals 0. How do I know that? Unit circle. You got to remember that stuff. So this piece here, that's 0. So I'm going to have, and that piece here, that's 1. So I'm going to have 4 times 1, or just 4, over 2. Now this is really 0 plus 2, so that's 2 square root 2. Keep going further with this. Let's say we simplify the 2 and the 4. That'd be a, well, no, that'd be a 1 down here and a 2 up here. So I'd have 2 over square root 2. Now if I check my answers, I don't really have that. But look at this. Check this out. If I do some rationalize the denominator on the top and bottom, then I would have 2 square root 2 over 2, which is just square root 2. E is the answer. Just about wrapping up this first one here. Let's see if we can finish it. Oh, this is a fun one. It's easier than you would think. Let's talk about it in terms of like velocity and speed and position and distance and that kind of stuff. I know this is talking about nautical mile per hour. That's like a speed or a velocity. Velocity. There we go. So if t is measured in hours, f prime t is measured in knots, so f prime of t is a velocity. Then what's the integral? Well, the integral of velocity from A to B is like a distance. That's like a distance kind of thing, or a displacement, either way. So when we're looking at this distance, you know, we're going to be taking the antiderivative of f prime of t, and that's going to give us f of t. So this, the antiderivative from A to B of f prime of t is going to be f of the top one, b, minus f of a. That's not a big deal, but the big deal here is, okay, so then it's d or e. Is it nautical miles or knots per hour? Well, think about this. The integral of v of t is distance, not a speed. And the distance would be measured in some type of distance measure. Which one of these two is a distance? Not a speed. Well, that's D. That's your clue, nautical miles. There are other ways to look at this graphically, but the general idea is when you take the antiderivative of a rate, like a speed, you wind up getting just a more simpler version of that, which would have been distance. Distance gives you D. All right, last one for this quick video here. Doing lots of these videos. The equation of a tangent line to the curve x squared plus y squared equals 169 at the point 5, negative 12 is. Okay, equation of the tangent line. Tangent line means this junk. Y minus y1 equals the slope times x minus x1. No big deal. They even give us y1 and x1. It's going to be y minus negative 12 equals the slope m times x minus 5. Alright, from this point I see that this becomes plus 12. I just have to figure out what the slope equals. M equals what? Well, that involves derivative. So I got to take the derivative of this. That involves implicit derivative because notice that this y squared is mixed in with the x and all that junk. So I take the derivative implicitly. That would give me 2x plus 2y dy dx equals 0. Do some algebra here. We got 2y dy dx equals negative 2x divided by 2y divided by 2y. And you got dy dx equals negative x over y. Wait, we have x and y. Here it is, x1 and y1. So we're going to plug that in. So when dy dx, this in case you didn't know. So slope equals dy dx when we have 5 and negative 12. So it's going to be negative, whatever x is, in this case 5, over negative 12, which is 5 over 12, positive, because we got 2 negative. Alright, so that's done. We got 5 over 12, no problem, right? Let's plug it in and see what we got. We'd have y plus 12 equals 5 over 12 times x minus 5. No big deal. Wait a second, I don't see any fractions up here, but there's one right here. So how do I deal with that? How do you get rid of denominators? Well, this is just algebra. How do you get rid of denominators? You multiply. So on this side, I'm going to multiply both terms by 12. That gives me 12y plus 144. On the other side, I multiply by 12. But look at this. It's all multiplied. It's like one big term here. This 12 and this 12, they simplify. So now it's just 5x minus 5, which is really 5x minus 25. All right. Now I'm a little closer to where I could, probably figure this out. I notice that I have 5x and 12y. So I'm going to cancel out d, e, and a. The question is it 5x minus 12y equals 119 or 5x minus 12y equals 169? Well, we got to do some stuff here. So it looks like I'm subtracting 12y. But then I'm adding 25. Aha! So it looks like it's going to be the 169. So we got 169 on this side equals 5x minus 12y. Cha-ching! There we go. C is the answer. Alright, so let's see what we got. Is that number 9? Is that number 9? Yeah, that's number 9. That's the first video for this sample test. We'll be converting it, uploading it onto YouTube. Come back and see this next one. Here's a quick preview of what it's going to be. Ready, set, sample test 1, numbers 10 through 18. Coming soon. Multiple choice.